The Capacitance Electronic Disc (CED) is an analog video disc playback system developed by RCA, in which video and audio could be played back on a TV set using a special needle and high-density groove system similar to phonograph records. First conceived in 1964, the CED system was widely seen as a technological success which was able to increase the density of a long-playing record by 2 orders of magnitude. Despite this achievement, the CED system fell victim to poor planning, conflicts within RCA, and technical difficulties that stalled production of the system for 17 years until 1981. By which time it was already made obsolete by LaserVision, DiscoVision, a.k.a. LaserVision and LaserDisc, as well as Betamax and VHS videocassette formats. Sales for the system were nowhere near projected estimates. In 1984, before it was absorbed by General Electric, RCA discontinued player production while discontinuing software production in 1986, losing an estimated $600 million in the process. RCA had initially intended to release the SKT425 CED player with a high-end Dimensia system in 1984, but cancelled CED player production just prior to the release of the Dimensia system. The format was commonly known as videodisc, leading to much confusion with the contemporaneous LaserDisc format. LaserDiscs are read optically with a laser beam, whereas CED videodiscs are read physically with a stylus, similar to a conventional gramophone record. The two systems are mutually incompatible. RCA used the brand SKT425 for the CED system, a name also used for some early RCA brand VCRs and other experimental projects at RCA. History, beginnings and release. RCA began videodisc research in 1964, in an attempt to produce a phonograph-like method of reproducing video. Research and development was slow in the early years, as the development team originally comprised only 4 men. But by 1972, the CED team at RCA had produced a disc capable of holding 10 minutes of color video. A portion of the Get Smart episode entitled Lumphong. The first CED prototype discs were multi-layered, consisting of a vinyl substrate, nickel conductive layer, glow discharge insulating layer and silicone lubricant top layer. However, failure to fully solve the stylus and disc wear and complexity of manufacturing forced RCA to search for simpler solutions to the problem for constructing the disc. The final disc was crafted using PVC blended with carbon to allow the disc to be conductive, to preserve stylus and groove life. A thin layer of silicone was applied to the disc as a lubricant. CED video discs were originally meant to be sold in jackets and handled by hand similar to audio records. But during testing, it was shown that exposure to dust caused skipped grooves. It was learned that if dust was allowed to settle on the discs, then the dust would absorb moisture from the air and cement the dust particle to the disc's surface, causing the stylus to jump back in a locked groove situation. Thus, an idea was developed in which the disc would be stored and handled in a caddy from which the CED would be extracted by the player so that exposure to dust would be minimized. After 17 years of research and development, the first CED player, model SFT100W, was released on March 22, 1981. A catalogue of approximately 50 titles was released at the same time. The first title to be manufactured was Race for Your Life, Charlie Brown. 15 months later, RCA released the SGT200 and SGT250 players. both with stereo sound, while the Sargent 250 was also the first CED player model to include a wireless remote control. Models with random access hit the market in 1983. Demise. Several problems doomed the new CED system almost from the start. From an early point in the development of the CED system, it was clear that VCRs and home videotape, with the longer storage capacity and recording capabilities, would pose a threat to the CED system. However, development pushed ahead. Once finally released, sales for the new CED system were slow. RCA had expected to sell 200,000 players by the beginning of 1982, but only about half had been sold, and there was little improvement in sales throughout 1982 and 83. The long period of development, caused in part by political turmoil and a great deal of turnover in the high command of RCA, also contributed to the demise of the CED system. RCA had originally slated the videodisc system for a 1977 release. However, the discs were still not able to hold more than 30 minutes of video per side, and the nickel-like material used by RCA to make discs was not sturdy enough to put into manufacturing. Signal degradation was also an issue, as the handling of the discs was causing them to deteriorate more rapidly than expected. Baffling engineers. RCA had hoped that by 1985 CED players would be in close to 50% of American homes. But the sales of players continued to drop. RCA attempted to cut the prices of CED players and offer special incentives to consumers, but sales did not recover. And by 1984, executives realized that the system would never be profitable and announced the discontinuation of production of CED players on April 4. In an unexpected twist, demand for the video discs themselves were high immediately after the announcement, so RCA alerted customers that video discs would be produced and new titles released for at least another 3 years after the discontinuation of players. After this announcement, however, the sale of discs declined sharply, prompting RCA to abandon disc production after only 2 years. The last titles released were The Jewel of the Nile by CBS, Fox Video, and Memories of Videodisc, a commemorative CED given to many RCA employees involved with the CED project. Both in 1986. How CEDs work. CEDs are conductive vinyl platters that are 30.0 centimeters, 11.8 in diameter. To avoid metric names, they are usually called 12-inch discs. A CED has a spiral groove on both sides. The groove is 657 nanometers wide and has a length of up to 12 miles, 19 kilometers. The discs rotate at a constant angular speed during playback, 450 revolutions per minute for NTSC, 500 revolutions per minute for PAL, and each rotation contains several full frames, 4 frames for NTSC, 3 for PAL. This meant that freeze frame was impossible on players without an expensive electronic frame store facility. A keel-shaped needle with a titanium electrode layer rides in the groove with extremely light tracking force, 65 milligrams, and an electronic circuit is formed through the disc and stylus. Like an audio turntable, the stylus reads the disc, starting at the outer edge and going towards the center. The video and audio signals are stored on the video discs in a composite analog signal, which is encoded into vertical undulations in the bottom of the groove, somewhat like pits. These undulations have a shorter wavelength than the length of the stylus tip in the groove, and the stylus rides over them. The varying distance between the stylus tip and the conductive surface due to the depth of the Undulations in the groove under the stylus directly controls the capacitance between the stylus and the conductive carbon-loaded PVC disc. This varying capacitance in turn alters the frequency of a resonant circuit, producing an FM electrical signal which is then decoded into video and audio signals by the player's electronics. The capacitive stylus pickup system which gives the CED its name can be contrasted with the technology of the conventional phonograph. Whereas the phonograph stylus physically vibrates with the variations in the record groove, and those vibrations are converted by a mechanical transducer, the phono pickup, to an electrical signal. The CED stylus normally does not vibrate and moves only to track the CED groove and the disc surface out of plane, while the signal from the stylus is natively obtained as an electrical signal. This more sophisticated system, combined with a high revolution rate, is necessary to enable the encoding of video signals with bandwidth of a few megahertz, compared to a maximum of 20 kHz for an audio-only signal, a difference of 2 orders of magnitude. Also, while the undulations in the bottom of the groove may be likened to pits, it is important to note that the spacing of vertical wave crests and troughs in a CED groove is continuously variable. As the CED is an analog medium, usually, the term pits, when used in the context of information media, refers to features with sharply defined edges and discrete lengths and depths, such as the pits on digital optical media such as CDs and DVDs. In order to maintain an extremely light tracking force, the stylus arm is surrounded by coils which sense deflection, and a circuit in the player responds to the signals from these coils by moving the stylus head carriage in steps as the groove pulls the stylus across the disc. Other coils are used to deflect the stylus to finally adjust tracking. This system is very similar to, yet predates, the one used in compact disc players to follow the spiral optical track, where typically a servo motor moves the optical pickup in steps for coarse tracking and a set of coils tilts the laser lens for fine tracking, both guided by an optical sensing device which is the analog of CED stylus deflection sensing coils. For the CED player, this tracking arrangement has the additional benefit that the stylus drag angle remains uniformly tangent to the groove, unlike the case for a phonograph tone arm in which the stylus drag angle and consequently the stylus side force varies with the tone arm angle, which in turn depends on the radial position on the record of the stylus. Whereas for a phonograph, where the stylus has a pinpoint tip, linear tracking is merely ideal to reduce wear of records and styly and to maximize tracking stability. For a CED player, linear tracking is a necessity for the keel-shaped stylus, which must always stay tangent to the groove. Furthermore, the achievement of an extremely light tracking force on the CED stylus enables the use of a fine groove pitch, i.e., fine spacing of adjacent revolutions of the spiral, necessary to provide a long playing time at the required high rotational speed, while also limiting the rate of disc and stylus wear. The disc is stored inside a caddy, from which the player extracts it when it is loaded. The disc itself is surrounded by spine, a plastic ring, actually square on the outside edge, with a thick, straight rim-like edge, which extends outside of, and latches into, the caddy. When a person inserts a caddy containing a disc into the player catches the spine, and both the disc and the spine are left in the player as the person pulls the caddy out. The inner edges of the opening of the caddy have felt strips designed to catch any dust or other debris that could be on the disc as it is extracted. Once the caddy has been withdrawn by the person, the player loads the disc onto the turntable, either manually with all SFT and most Sargent prefix RCA players, or automatically with the RCA Sargent 250, and all other models and brands of players. When playback has been started, the player spins the disc up to speed while moving the pickup arm over the disc surface and lowering the stylus onto the beginning of the disc. When stop is pressed, the stylus is lifted from the disc and returned to its parking location, and the disc and spine are lifted up again to align with the caddy slot. When ready, the slot is unlocked, and the caddy can be inserted and withdrawn by a person, now with the disc back inside. Advantages. CED players, from an early point in their life, appeal to a lower income market more than VHS, Betamax, and LaserDisc. The video quality, approximately 3 MHz of luma bandwidth for CED, was comparable to a VHS SP or Betamax 2 video, but subpar compared to LaserDisc. About 5 MHz of luma bandwidth. CED players were intended to be low-cost, because they have fewer precision parts than a VCR. A CED player cost, at most, about half as much to manufacture. The discs themselves could be inexpensively duplicated, stamped out on slightly modified audio gramophone record presses, like VCRs. CED video disc players had features like rapid forward, reverse and visual search forward, reverse. They also had a pause feature, though it blanked the screen rather than displaying a still image. Many players featured a page mode, during which the current block of 4 successive frames would be repeatedly displayed. Since CEDs were a disc-based system, they did not require rewinding. Early discs were generally monaural, but later discs included stereo sound. Monaural CED discs were packaged in white protective caddies, while stereo discs were packaged in blue protective caddies. Other discs could be switched between 2 separate mono audio tracks, providing features such as bilingual audio capability, like the LaserDisc and DVD. Some CEDs feature random access and that users can quickly move to certain parts of the movie. Each side of a CED disc could be split into up to 63 chapters or bands. 2 late RCA players, the SKT400 and SKT400, could access these bands in any given order. Unlike its laser-based counterparts, the chapters in a CED are based on minutes of the film, not scenes. Novelty discs and CED-based games were produced whereby accessing the chapters in a specified order would string together a different story each time. However, only a few were produced before the halt of CED player manufacturing. Disadvantages. In comparison with LaserDisc technology, CEDs suffered from the fact that they were a phonograph-related contact medium. RCA estimated that the number of times a CED could be played back, under ideal conditions, was 500. By comparison, a clean, laser-rot-free LaserDisc could, at least in theory, be played an unlimited number of times, although repeated handling might still result in damage. Since the CED system used a stylus to read the discs, it was necessary to regularly change the stylus in the player to avoid damage to the video discs. Worn and damaged discs also cause problems for consumers. When a disc began to wear, video and audio quality would severely decline, and the disc would begin to skip more. Several discs suffered from a condition called video virus, where a CED would skip a great deal due to dust particles stuck in the grooves of the disc. However, playing the disc several times would generally solve this problem. Unlike VHS tapes, CEDs required a disc flip at some point during the course of almost all films. Because only 60 minutes of video could be stored per side, if a feature ran over 2 hours, it would be necessary to spread the feature over 2 discs. In some cases, if a movie's theatrical running time was only slightly longer than 2 hours, from 120 minutes and a few seconds to 122 minutes, studios would often trim short scenes throughout the movie or employ time compression, speeding the extra runtime out of the film, in order to avoid the expense of issuing 2 discs. This problem was not unique to CEDs, as LaserDiscs presented the same difficulty, and some longer features, such as the Ten Commandments, 1956, still required more than 1 tape per disc in the VHS, beta, and LaserDisc formats. Less significant disadvantages include lack of support for freeze frame during pause, since CEDs scanned 4 frames in 1 rotation versus 1 frame per rotation on CAV LaserDisc. Nor was computer technology advanced enough at the time to outfit the player with a frame buffer affordably. However, a page mode was available on many players that would allow for those 4 frames to be repeated in an endless loop. CEDs were also larger than VHS tapes, thicker than LaserDiscs, and considerably heavier due to the plastic caddies. Available material. Players. CED players were manufactured by 4 companies: RCA, Hitachi, Sanyo, and Toshiba, but 7 other companies marketed players manufactured by these companies. Media. Upon release, 50 titles were available for the CED, along with RCA, which included the company's partnership with Columbia Pictures plus Paramount and Disney releases. CBS Video Enterprises, later CBS, Fox Video, produced the first 50 titles. Eventually, Disney, Paramount Pictures, MCA, MGM, Bestem Video, and other labels began to produce CED discs under their own home video labels, and did so until the end of disc manufacturing in 1986. See also: LaserDisc, videodisc, videotape format war. Further reading: Cowie, Jefferson R. Capital Moves. RCA's 70-year quest for cheap labor. Ithaca, N.Y. Cornell University Press. 1999. ISBN 0-8014-35250. Daines, Rob and Beverly Butler. The Videodisc Book. A Guide and Directory. New York. John Wiley & Sons. 1984. ISBN 0-471-80342-1. DeBlois, Michael L. ed. Videodisc, Microcomputer Courseware Design. Englewood Cliffs. N.J. Educational Technology Publications. 1982. ISBN 0-877781834. Floyd, Steve, and Beth Floyd, eds. The Handbook of Interactive Video. White Plains, NY. Knowledge Industry Publications. 1982. ISBN 0-86729-019-6. Graham, Margaret B. W. RCA and the Videodisc. The Business of Research. Also as The Business of Research. RCA and the Videodisc. Cambridge. Cambridge University Press. 1986. ISBN 0-521-32282-0. ISBN 0-521-36821-9. Haynes, George R. Opening Minds. The Evolution of Videodiscs and Interactive Learning. Dubuque, Iowa. Kendall, Hunt Publishing Co. 1989. ISBN 0-8403-51917. Howe, Tom. CED Magic. The RCA Video Disc Collector's Guide. Portland, OR. CED Magic. 1999. ISBN 0-9670013-07. CD-ROM. Isilovic. Jordan. Video Disc and Optical Memory Systems. Englewood Cliffs. N. J. Prentice Hall. 1985. ISBN 0-13-942053-3. Lardner, James. Fast Forward. Hollywood. The Japanese. And the VCR Wars. Also as Fast Forward. Hollywood. The Japanese. And the Onslaught of the VCR. New York. W. W. Norton and Co. Inc. 1987. ISBN 0-393-02389-3. Lenk, John D. Complete Guide to Laser Video Disc Player Troubleshooting and Repair. Englewood Cliffs. N. J. Prentice Hall. 1985. ISBN 0-13-160813-4. Schneider, Edward W. and Junius L. Brenyan. The Instructional Media Library. Video Discs. Volume 16. Englewood Cliffs. N.J. Educational Technology Publications. ISBN 0-87778-176-1. 1981. Sigel, Ephraim. Mark Shubin and Paul F. Merrill. Video Discs. The Technology. The Applications in the Future. White Plains. N. Y. Knowledge Industry Publications. 1980. ISBN 0-91423656-3. ISBN 0-442-27784-9. Sobel, Robert. RCA. New York. Stein and Day Publishers. 1986. ISBN 0-8128-3084-9. Sonnenfeldt, Richard. Mehralseinleben. More Than One Life. 2003. ISBN 3502-18680-4. In German. Journals. The Video Disc Monitor. Video Disc News. Video Disc. Optical Disc Magazine. Video Computing. The Total Rewind VCR Museum. Covering CED and other vintage formats. RCA Video Disc Website. CED Magic. The LaserDisc Database. LD, CED, VHD discs. Profiling and Marketplace. Electron Microscope shows how CEDs are played. Retrotech. The RCA CED Video Disc.